a rock small enough to disappear into a pocket, a structure invisible to the naked eye, and a geological process so improbable that when everything aligns perfectly, the result can be worth more than a luxury home. Some exceptional opals have sold for tens of thousands of dollars. Others have reportedly sold for hundreds of thousands, and a select few have entered the realm of multi-million-dollar collectibles. But unlike diamonds, opals have no universal grading authority and no single global pricing system. Their value emerges from a combination of geological rarity, collector demand, documented sales history, and one simple question: how often does nature actually produce what you're looking at? Today we're ranking some of the most valuable opals on Earth, not according to folklore, not according to superstition, but according to the geological evidence hidden inside the stones themselves. Professional gemologists and advanced collectors typically evaluate four major indicators: body tone, brightness, pattern, and color composition. Every one of these characteristics leaves clues about the conditions under which the opal formed. And our ranking begins with an opal that never fully leaves the rock that created it. Number 5. High-grade boulder. Exceptional specimens have reportedly sold from tens of thousands into the low hundreds of thousands of dollars. Most gemstones are separated from their host rock before they're sold. Boulder opal is different. These opals formed when
All forms of silica are made from the same elements,
fractures
but they have
and
different
cavities
structures.
within iron-rich sedimentary rocks millions of years ago. The surrounding ironstone remained, and in the highest value specimens, that host rock becomes part of the finished artwork. The first clue experienced buyers evaluate isn't color, it's brightness. Does the play of color remain visible under natural lighting, or does it disappear except under direct illumination? The finest boulder opals maintain strong color under nearly all viewing conditions. The second clue is spectral diversity. Blue and green are relatively common. Orange becomes less common. Strong red fire is exceptionally rare, and when multiple saturated colors appear together, value can increase dramatically. Collectors also study pattern structure, rolling flashes, ribbon formations, broad sheets of color, and occasionally structures resembling the legendary harlequin patterns of black opal. In exceptional Queensland specimens, the ironstone matrix doesn't compete with the gem. It frames it. Museum-quality boulder opals have reportedly sold for well into six figures, but some opals create something even more valuable than brightness. They create depth. Number 4. Crystal opal. Exceptional specimens have reportedly sold for hundreds of thousands of dollars. At first glance, crystal opal appears almost fragile, transparent, delicate, glass-like. But that transparency produces one of the most remarkable visual effects in gemology. Depth, not surface color, depth. Light penetrates deep into the stone before returning to the observer, creating the appearance of illuminated layers suspended within transparent space. The effect has often been compared to looking into a glowing nebula. For collectors, one of the most important clues is directional stability. Does the color disappear as the stone rotates, or does it remain visible from multiple viewing angles? The finest crystal opals maintain intense color throughout movement. Red, orange, green, violet, not appearing as isolated flashes, but as layered fields of color existing at different depths within the same specimen. That optical stability is uncommon, and when combined with exceptional transparency and strong red spectral components, values increase rapidly. Several significant Australian crystal opals have reportedly achieved six-figure valuations through private sales. But during the early 21st century, discoveries in East Africa challenged long-standing assumptions about where world-class opals could originate. Number 3. Ethiopian black crystal opal. Exceptional specimens have reportedly sold from the high five figures into the hundreds of thousands. When Ethiopian opals first entered international markets, many collectors considered them an emerging category. That changed quickly. The finest Ethiopian black crystal opals possess a combination of properties rarely found together: exceptional brightness, high transparency, and extraordinary color saturation. The first clue experts evaluate is body tone. A darker background increases visual contrast, allowing spectral colors to appear dramatically brighter. The second clue is movement. Some Ethiopian specimens display broad flashes that appear to drift beneath the surface. Others exhibit rolling structures that create the illusion of liquid light. Instead of observing individual flashes, the viewer experiences entire landscapes of shifting color. Their geological origin also differs significantly from Australia's famous sedimentary opals. These stones formed within volcanic environments, and under the right conditions, those volcanic systems produced opals with extraordinary optical intensity. The finest examples permanently altered the perception of Ethiopian opal in the international market. Yet one locality still dominates the highest level of opal collecting. Number 2, Australian black opal. The finest documented specimens have achieved values ranging from hundreds of thousands to several $1 million. For more than a century, one location has defined the global opal market: Lightning Ridge. And among collectors, one pattern remains legendary: Harlequin. Unlike broad flash or rolling fire patterns, Harlequin structures display organized geometric patches distributed across the surface of the stone. The geological conditions required to create this level of microscopic order are extraordinarily rare. Experienced collectors evaluate 3 primary clues: pattern regularity, brightness, and the presence of strong red spectral fire. Red is especially important because producing red wavelengths requires exceptionally precise internal structures. Some of the world's most famous specimens, including the legendary Aurora australis discovered in Lightning Ridge in 1938, demonstrated just how valuable these characteristics could become. When exceptional brightness, strong red fire, and highly organized harlequin patterning occur together, an opal ceases to be merely a gemstone. It becomes a geological rarity, and in the rarest cases, a museum object. But there exists one category of opal so unusual that color alone cannot explain its value. Its rarity isn't determined only by brightness, or by pattern, or even by body tone. Its value originates from a geological structure so uncommon that many experienced collectors will never encounter one in person. To understand why certain opals have reportedly achieved values approaching $2.5 million, we have to examine a phenomenon hidden far deeper inside the stone itself, and that's where our ranking continues. The most valuable opals on Earth do not simply contain color. They contain order, not the kind of order visible to the naked eye, the kind measured in fractions of a micron. And when that order reaches an extreme level of natural perfection, the result can become one of the rarest gemstones ever produced by geological processes. This is the highest tier of the opal world. Number 1. Museum-grade red harlequin black opal. The rarest documented specimens have been valued from the high 6 figures into the multi-million-dollar range. For more than a century, miners, gemologists, and collectors have searched for one particular combination of characteristics. Not just black opal, not just red fire, not just harlequin pattern, all 3, simultaneously. To understand why this combination is so valuable, you have to begin with the first observable clue: pattern regularity. Most precious opals display color in irregular flashes. Some exhibit broad patches, others display rolling waves of color. But harlequin opal behaves differently. Instead of random flashes, the stone displays a mosaic, a repeating arrangement of angular color blocks, squares, rectangles, diamond-shaped segments, each one flashing independently, and each one revealing something extraordinary about the geological conditions under which the stone formed. Precious opal forms when microscopic silica spheres become arranged in orderly layers. The size and spacing of these spheres determine which wavelengths of light become visible. Blue requires one range of structures. Green requires another. Red, the rarest and most valuable color, requires exceptionally precise organization, and harlequin patterns require an even greater degree of order. The probability of both occurring together naturally is extraordinarily low, which is why collectors have spent generations searching for them. The second clue experts evaluate is brightness, not simply whether color exists, but how intensely it performs. Gemologists often describe brightness using comparative grading scales. Can the colors compete with daylight? Do they remain visible under diffuse illumination? Or do they require direct light to appear? The finest black opals maintain extraordinary brightness regardless of viewing conditions. And when that brightness combines with red harlequin patterning, values can increase dramatically. The third clue is geographic origin. Although precious opal occurs in numerous countries, Lightning Ridge has produced the overwhelming majority of the world's finest black opals. Its unique geological history created conditions that remain poorly replicated elsewhere. Approximately 100 million years ago, silica-rich groundwater migrated through ancient sedimentary deposits. Over immense periods of time, microscopic silica spheres accumulated with extraordinary precision. Most deposits produced ordinary common opal. A small percentage produced precious opal. An almost unimaginably small percentage produced museum-grade black opal. And an even smaller percentage produced red harlequin black opal. One specimen helped define this category: the Aurora australis, discovered at Lightning Ridge in 1938, weighing approximately 180 carats. Displaying exceptional red and green harlequin patterning against a naturally dark body tone, it became one of the most famous opals ever discovered. Not because it was the largest, but because it demonstrated what geological perfection could look like. Collectors did not simply see color, they saw improbability. A collector evaluating a world-class black opal typically asks 5 questions. How dark is the body tone? How strong is the brightness? How rare is the pattern? How dominant is the red fire? And how stable is the optical performance during movement? If one category scores highly, the stone becomes valuable. If several categories score highly, the stone becomes extremely valuable. But when all 5 align simultaneously, the specimen enters an entirely different market. And this is perhaps the most important lesson for prospectors and collectors. Value does not emerge from beauty alone. It emerges from evidence, visible evidence, observable evidence, geological evidence, a flash of red, a geometric pattern, an unusually dark body tone, a brightness that persists under changing light. Every one of these characteristics tells part of the story, and together they reveal how improbable the specimen really is. From Queensland boulder opals worth tens of thousands of dollars, to transparent crystal opals exhibiting extraordinary depth, to Ethiopian black crystal opals that transformed the global market, and finally to museum-grade red harlequin black opals capable of reaching extraordinary valuations. The ranking ultimately reveals a simple truth. Nature does not reward size, nature rewards rarity. And sometimes, the rarest geological events on Earth can fit in the palm of your hand. If you enjoy examining the geological clues hidden inside gemstones, minerals, and prospecting discoveries, consider subscribing, because the next remarkable discovery may already be sitting unnoticed inside an ordinary-looking rock.